Hello! Today we're going to be doing Introduction to Vectors. So it's just going to be a little bit about vectors that'll get you prepared for adding vectors, the multiple cases in which you add vectors, or basically calculate the resultant of a vector question. Okay, so scalars are quantities that have only magnitude, and examples of that would be time, temperature, distance, perimeter, area, volume, and speed. A vector are quantities that have both magnitude and direction. And examples of this would be velocity, acceleration, force, torque, direction, and position. So what does it look like? Well, a vector is sort of like an arrow with a tail and a tip or a head. And this would be A and this would be B. Vectors have both direction and magnitude, and that's from Despicable Me, the children's movie that came out not too long ago. So, opposite vectors have the same magnitude but opposite direction. Equivalent or equal vectors have the same magnitude and same direction. Direction of vectors. So this is sort of like our compass here. We have north, east, south, and west. And then we have northeast, southeast, southwest, and northwest. So those are like, it can be pointing north. And if it's in between north and east, then it's pointing northeast. It could be pointing south, but if it's in between east and south, it would be southeast. And the same goes for southwest and northwest. 90 degrees would be the distance or the degree distance between north and east. And halfway through, so directly northeast would be 45 degrees this way, and 45 degrees would be left over here. So this is a little bit about the direction of vectors. You're gonna get multiple questions that will say, oh, it is 45 degrees northwest, which means it would be pointing this way. And then there will be another vector that says it's pointing north. So you're left with So there will be questions like that. That's why we have the direction of vectors. And just a little sketch of a vectored question. Okay, moving on. So we have true bearing. So it starts from north and go clockwise. The direction has 3 digits and are placed in these types of brackets. So for example, if it's pointing directly north, the degrees would be 0, 0, 0, 0 degrees. 3 zeros. If it's pointing east, then the degrees would be 0, 90 degrees. If it is pointing south, it would be 180 degrees. If it is pointing west, it would be 270 degrees. And then I have, so you see I have different vectors going in different directions. or arrows, I would say. And right here would be about 20 degrees. So that is how I would put a true bearing vector. It's just another way to measure the angle in which the vector is pointing. And you go clockwise, like pretend it's a clock. You go clockwise, so this direction, and you start at north, and it's another way to measure vectors. So you might see a question that has true bearing measurements of angles instead of our directions here. So hopefully that made sense. I also have 140 degrees, so that vector will lie upon this arrow, and our calculation would be 140 degrees, and it would be placed in these brackets. And then I have 235 and 330 as well. Moving on. So we have quadrant bearing. So this one was true bearing, and this one is quadrant bearing, which I think quadrant bearing is more common, but you can see both that will be in various types of questions. So you can see both. It's important to know both before you get into vectors, and I'll try to feature questions that have both, or I'll do both of the angle measurements and like true bearing and quadrant bearing measurements, just in case your teacher prefers one or the other, or that you have different questions and you're not quite sure how to solve it. So it's a measure of an angle between 0 and 90 degrees, east or west of the north or south line. So right here, I have north 20 degrees east. So it's 20 degrees from the north line, north. See, I'm going to show you something. So it's north 20 degrees east. If I had this line and it was 20 degrees here, then it would be east 20 degrees north. Normally, we do north and south first, but if you were to, if there was 20 degrees going this way, then it would be east 20 degrees north. But we have north 20 degrees east, so here's 20 degrees. We would, if we saw this, north 20 degrees east, we would just go 20 degrees from the north line, make our vector or our arrow 20 degrees, and then that would be our vector, and it would be placed properly. So now I have south 40 degrees east, so this angle right here is 40 degrees, and it lies directly upon this arrow or this vector, and it's in those brackets as well. So south 40 degrees east. If I were to have east 40 degrees south, then I would go 40 degrees down this line, and this would be 40 degrees. So whatever letter appears here first, is where you're going from. So if it was E, I would be going from this line and then making an arrow. If it was going from south, I would be going from this line and then making an arrow from the center. If it started with W, then I'd be going from this line and making a vector from that. If it starts with north and it ends with a W, then you're going this way, towards the W. If it starts with N and it ends with E, then you're going this way. It does not, we don't have N and S here. That's not correct. It's not correct. You'll never see N and S because there's a W and the E in the way, and it's a measure of an angle between 0 and 90 degrees, east or west of the north or south line. So I have south 55 degrees west, so that means that this angle is 55 degrees, and I'm going from the south line because that's the first letter, and then it ends with W, it ends with west. I have north 30 degrees west, and I'm going from the north line because that's the first letter, and I'm going 30 degrees towards west. So this is 90 degrees, and I'm going 30 degrees towards west. So I hope that makes sense, and that's a little bit about vectors, what they are, what does it look like, direction of vectors and both types. So I hope that you found that helpful, and I'll be doing adding vectors and application questions, so have no fear, and we'll be doing lots more on this soon. So thank you very much and have a great day.